Following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. So today we're going to go on to section 8.4. Before we do that, are there any questions from 8.3 at this time? Anybody, any questions? Alrighty then, we'll go on to section 8.4. Which deals with inequalities and solving compound inequalities. So first of all, let's take a look at some problems where we have some sets of numbers. And first of all, we have set A. And within set A, we have the following numbers or elements: 0, 1, 2, 3, 4, 5, and 6. Then we have set B that contains the following numbers or elements: 4, 6, 8, and 10. Then we have set C, which has -3, -1, 0, 1, and 2. And finally, set D that contains the numbers or elements -3, 1, 2, 5, and 8. Okay. So each of these sets has certain numbers or elements in it, as we can see here. I want to talk about a couple of symbols and a couple of ideas. So we'll come back to that in a minute. Let's say that this is Nob Hill Boulevard, and this is 16th Avenue. So basically the college, the main part of the college is right here, though now there's parts of the college here, and who knows, someday. This piece right here, is that part of 16th Avenue? Yes, it is. Is it part of Nob Hill Boulevard? Yes, it is. It's what we call the intersection of 16th Avenue and Nob Hill Boulevard. It's the part that is in both of them simultaneously or at the same time. So again, this piece of property right here is part of Nob Hill Boulevard and is part of 16th Avenue. So the intersection is where two sets overlap. Okay. Now, suppose we wanted to talk about all of Nob Hill Boulevard along with all of 16th Avenue. Then we would be talking about all of this, and again, it goes in both directions, and all of this. Oops. Okay. So that would be what we call the union. The union is all of both put together. The intersection is that which they have in common. Now, the symbol for union is this, which looks very much like a U, but without the little tail. The symbol for intersection looks like this, or sort of an upside down U. Okay. So now let's go back to this group of sets, and let's consider the following. A intersected with D. So we want the set of numbers that are in A and at the same time in D. So let's see, that would include 1, 2, and 5. Those are the numbers that are in both A and D, therefore they are in the intersection of A and D. Any questions about this example? Okay, let's take a look at this one. B in union with C. So we want the union of B and C, which means all of B along with all of C. let's see. We've got -3, -1, 0, 1, 2, 4, 6, 8, and 10. See if I can do a better job of making that. Here we go. So the union of B and C are all of B along with all of C. And let's see here. Let's take a look at the union of A and C. So that would be all of A along with all of C, -3, -1, 0, 1, 2, 3, 4, 5, 6. Notice that I don't list the elements that are in both twice. For instance, 0, 1, and 2 are in both A and C, but I don't list 0 twice, 1 twice, and 2 twice, okay? So when you're listing the union, you just have to list each element that exists in either one just one time, okay? Let's see, let's get rid of that. Now, what about this? The intersection of B and C. B contains 4, 6, 8, and 10. C contains -3, -1, 0, 1, and 2. There is no intersection. There's nothing they have in common. So there are two different ways we can do this. We can make set notation with nothing in it. This is referred to as an empty set. Or we can use this symbol called the null set, which again means that it's an empty set. Now, I've noticed that some people in the military come in and they use this as a 0, but in mathematics, this means an empty set or no solution. Be careful not to do this. If you put the symbol for an empty set inside of an empty set, then there's something in the empty set and it's no longer empty, okay? So you want to use either this or that to imply that there's no solution, no intersection. B and C have nothing in common. Okay, let's see here. Any questions about that before we move on? So we've got these two symbols for union and for intersection, that. All right. In a different context, instead of using these symbols, we use the words or as well as and, where or means union and means intersection. The way I always remember that is that this letter in the middle looks an awful lot like the symbol for intersection. Okay, so now let's take a look at some other examples. It says, solve each compound inequality. If possible, graph the solution set, if one exists, and write it using interval notation. All right. So first of all, let's see, this is problem 25, which is in the book, doesn't matter, just for reference. So we've got the following inequalities. X is greater than -2, and X is less than or equal to 5. All right. So we are to solve this compound inequality, graph it on a number line, and write the solution in interval notation. Okay, now, each of the individual inequalities, x greater than -2, x less than or equal to 5, is already solved. But we want the intersection. It isn't required to graph the individual pieces, but I found that it's easier for students to visualize it if we do. So let's take a look at x greater than -2. Okay. So let's see here, we've got 0 and 1 and 2. And -1 and -2. X greater than -2, we would have parentheses at -2 and an arrow pointing to the right. So that says that everything greater than -2 is part of the solution of that first inequality. Okay, let's take a look at the second one. X less than or equal to 5. x less than or equal to 5. So now we'd have a bracket at 5 and an arrow going to the left. Okay. Any question about those two individual pieces? But we want the intersection. We want to know what they have in common. Now keep in mind that this continues on and this continues on. Okay. So where do they overlap? Well, from here to there. Here, let's extend that even further. Okay. So if we were to graph the intersection, it would include everything from here to there. That's where the two overlap. Okay. So that means what? We've got -2 less than x less than or equal to 5. And an interval notation that would look like this. Okay. So we've solved it. Here is interval notation and here is the graph. Everything between -2 and 5, not including -2, but yes, including 5. Any questions on this example? All right, let's take a look at another one. Let's see, this is 29. It says 6x plus 1 less than 5x minus 3 and x over 2 plus 9 less than or equal to 6. Now, same directions, only here our inequalities have not been solved first. So we're going to take a look at that first one, 6x plus 1 less than 5x minus 3, and solve it. We're going to solve it for x, and we're going to solve it for x on the left side of the inequality. So I'm going to subtract 5x from both sides, which gives me x plus 1 less than -3. Then I'll subtract 1 from both sides, x less than -4. Then the second one, I'm going to subtract 9 from both sides. So I get x over 2 less than or equal to -3. I'm going to multiply both sides by 2. So I get x less than or equal to -6. And I'll bring the and down. So now the two inequalities have been solved. From here, we'll go on just like we did in the first example. So x less than -4. Let's see here, 0, -1, -2, -3, -4. So it's going to look like that. Again, since it doesn't include the equals, we use parentheses. If it does include it, we use brackets. Okay. And then x less than or equal to -6. That's going to look like that. Okay. Where do these two overlap? Because we're talking about the intersection. Well, this one continues on in this direction, as does this one, right? So right there. So graphically, let's see what that would look like. We'd have, well, let's see here. 0, say what, -6, and it's going to be a bracket, and then going that way. That would be the intersection, and in interval notation, -infinity up to and including, so bracket on 6. excuse me, on -6. Any questions there? Okay. Let's take a look at another example. Let's see here. This is 31. We've got x plus 2 less than -1/3 x and -6x less than 9x. Okay. So again, we're going to solve each inequality and solve it so that x is on the left side of the inequality. So the first one, I'm going to add 1/3 x to both sides. So now I get 1 1/3 x, but I'm going to write that as 4/3 x plus 2 less than 0. Okay, 1 1/3 is 4/3. Then I'm going to subtract 2 from both sides. 4/3 x less than -2. Then we'll multiply both sides by the reciprocal of the coefficient of x. So the coefficient is 4/3, the reciprocal is 3/4. That gives me x. And then over here, let's see, that would be -1/2. So what, -3/2. So x is less than -3/2. Okay. And then here, let's see, I'm going to subtract 9x from both sides. So I get what, -15x less than 0. Then I'll divide both sides by -15. Do you remember what you do if you multiply or divide both sides of an inequality by a negative number? You change the direction of the inequality symbol. Okay. Again, when you multiply or divide, and only when you multiply or divide both sides of an inequality by a negative number, you change the direction of all the inequality symbols. Okay, so I've got this and this.
Mr. Mayo, how did you get 4/3?
Okay, let's go back here. Okay, so x plus 1/3 x would be 1 1/3 x. Are you okay with that?
Yeah.
But what's 1 1/3? That's 4/3. 1 plus 1/3 would be 3/3 plus 1/3, which is 4/3.
Oh, okay.
Okay.
Yeah, I got it.
Alrighty. I could probably just leave that there, I guess. But anyway. Okay. So let's graph this. Here's 0, and here's what, -3/2. So the graph is going to look like this. And then we've got x greater than 0. So that graph is going to look like that. Where do they intersect? They don't. So the solution, no solution. They have nothing in common. They wanted the intersection. They had nothing in common. All right, any questions there? Okay. Now we're going to look at what is called a double inequality. It says solve each double inequality, graph the solution set, and write it using interval notation. So this is number 33. It says 4 less than or equal to x plus 3 less than or equal to 7. So the idea here is we need to solve this inequality, this double inequality as it's called, for x or whatever variable in the middle piece. There's 3 pieces here. There's the middle, and then there's a right end and a left end. So anything I do to one piece, I have to do to all 3. I'm trying to get x by itself in the middle. So I'm going to subtract 3 from the middle, which means I'm going to subtract 3 from each end as well. So now I get 1 less than or equal to x less than or equal to 4. and we've solved for x. How would you write that in interval notation? Like that. And how would you graph it? Oops, that's not what I wanted to do. Let's see, 0, 1, 2, 3, 4. We've got from here to there, like that. Okay. Any questions on that one? Let's take another look at one of those. So this is another double inequality. So let's see, this is 36, 7 less than 3x minus 2 less than 25. Okay, so I'm going to add 2 to each piece. So I get 9 less than 3x less than 27. Then I'm going to divide each piece by 3. So I get 3 less than x less than 9. In interval notation, it would look like that. And on the graph, let's see, 0, 3, 9, and we've got what? That, and then that. Questions on that example? All right. So we've looked at some intersections and some double inequalities. Now we're going to look at some union situations. It says solve each compound inequality, graph the solution set, and write it using interval notation. So we've got x less than or equal to -2 or x greater than 6. Recall that or means union and means intersection. Okay. Well, these two inequalities are already solved individually. So again, let's take a look at their graphs. X less than or equal to -2. Let's see. So this one would look like that. Okay. And then x greater than 6. This one would look like that. Before we finish this problem, I want to talk about the state of Hawaii. Okay, so Hawaii consists of several different islands. Okay, they're all part of the state of Hawaii. So if we talk about the state, the Union of Hawaii, it includes several different land masses that are geologically or geographically, I guess, both separate from the others. So you've got a piece of land here and a piece of land here and a piece of land there. Okay. So if we want the union of these two, we're going to have this piece. It's not, yeah, along with this piece. So this would be the graph of the union. Now, since the two pieces are separated geographically, when I write them in interval notation, it's going to require more than one interval. So I'm going to have from -infinity up to and including -2 in union with, after 6, going up to +infinity. Okay. So the union still has two separate pieces. We can't combine them because there's a space between them, just like different islands in the state of Hawaii. Any question about that one? Okay. Let's see here. Let's take a look at this one. 2x greater than x plus 3, or x divided by 8 plus 1 less than 13/8. Okay? So to solve the first inequality, I'm going to subtract 1x from both sides, so x is greater than 3. X is greater than 3. Okay? The second one, let's see. I'm going to multiply both sides by 8. So that's going to give me what? X plus 8 less than 13. Everybody okay with that? 8 times x over 8 would be x. 8 times 1 is 1. Excuse me, 8 times 1 is 8. 13/8 times 8, the 8s would reduce. Okay, so then we're going to subtract 8, and we get x less than 5. So here we have our two inequalities, and they've been solved. In fact, here, let's write this down here. So that's what we're going to deal with. All right. So let's take a look at the graphs. X greater than 3 would look like this. And then x less than 5 would look like this. But we want the union. Well, if you take all of the top graph along with all of the bottom graph, if you put them together, your graph is going to be the entire number line. So interval notation would be all real numbers, negative infinity to positive infinity. Okay? Now, be careful that you don't get intersection and union mixed up. If we were talking about the intersection, it would just be from here to here, wouldn't it? But it's union, not intersection. Okay? So this means union, this means union, this means intersection, this means intersection in the context of these inequality problems. Okay? While I'm thinking about it, I want to talk about in WebAssign, you need to be very careful in graphing the solutions. Okay? One of the things is the scales on the number lines are sometimes kind of tricky. Like they might have something like this where this is 0 and this is 5, but instead of having 5 equal increments between 0 and 5, they'll only have 4 of them. So you really have to pay close attention to your fractions. Okay. If you're really, really close, it tends to mark it right. But if you're off, it's going to mark it wrong. So make sure you pay close attention to what you're doing in terms of the graphic. Okay, let's see here. I want, let's take a look at this one. Thing keeps shifting on me. Let's see if I can get this thing. 50. There we go. All right. -6 less than -3 times x minus 4 less than or equal to 24. So this is a double inequality. I need to solve for x in the middle. The first thing I'm going to do is distribute. So I get -3x plus 12 in the middle. Next, I'm going to subtract 12 from all 3 pieces. So I get that. And then finally, I'm going to divide everybody by -3. So this is what? 6x -4. But because I divided each piece by a negative number, I've got to change the direction of each inequality. However, now we need to take this and we need to write it from smallest to largest. So we're not going to switch the sign. We're going to turn the whole thing around, a different viewpoint, okay? Let's see, is there somebody that's willing to, well, let's just say, okay, YOLO, I don't know how old you are, but I'll bet that I am older than you, okay? So we could say Ben is older than YOLO. But if I'm older than you, wouldn't it be true that you are younger than me? So we could say YOLO is less than or younger than Ben. They're really the same statement, just different viewpoints, okay? So I've turned it around, but I didn't change the sign in terms of the relationship. So what does that mean? That means right here, we're going to write it like this. Oops, -4. Okay. So the first one you'd say what? X is less than 6 and greater than or equal to -4. And the second one you'd say X is greater than or equal to -4 and less than 6. So they're saying the same thing. It's important that you write it that way, because then when you go to put it in interval notation, it's going to look like this. If you write it in interval notation like this, that's going to be wrong, because in an interval, it has to go from smallest to largest. So be careful with that. Same thing when you go to graph it. Let's see here, we're going to have 0 and 6 and -4. It's going to be like this and like that, not the other way around. So if you made your graph like this, that's incorrect, okay? So if you end up dividing or multiplying all three pieces and changing the sign, then take a look, you're probably going to have to flip the thing around before you change it into interval notation or graphing. All right, let's take a look at one with some decimals. This is 62. So we've got y plus 0.52 less than 1.05 y, or let's see here, 9.8 minus 15y greater than -15.7. Okay, so we've got decimals. We can live with them or get rid of them. Well, let's get rid of them. So just to review how you do that. In this problem, I need to move the decimal point 2 places to the right, which means I'd need to multiply both sides of the equation by 100. And then distributing, I would get 100y plus 52 greater than 105y. Okay? Any questions there? So now I'm going to come back and I'm going to subtract 105y from both sides. So I get -5y plus 52 less than 0. Okay. Then I'm going to subtract 52 from both sides. -5y less than -52. And then finally divide both sides by -5. So I get y, what, greater than 52 fifths. Okay, y 52 fifths, negative divided by negative is positive. Okay, I've divided both sides by a negative number, so I'm going to change the direction of the inequality sign. 52 fifths is 10.4. Now, why would I change it to 10.4? I wouldn't have to, but since my original problem had decimals, I'm just going to go back to decimals. All right, let's take a look at the second inequality. I'm going to subtract 9.8 from both sides, so -15y greater than -25.5. Is that right? Let's see here. Let's check. -15.7, and then minus 9.8, negative 25.5, and I'm going to divide both sides by negative 15. So y is greater than, excuse me, y is less than, let's see, 25.5, negative divided by negative is positive. 25.5 divided by 15 is 1.7. Okay, so I'm going to bring this down here, and I'm going to take that and go to the next page. Okay, hang on here just a second. So I'm going to have what? Y is greater than 10.4, or y is less than 1.7. Okay. Any questions on this page before we go on? So let's see here. If I were going to graph y greater than 10.4, it would look like that. I'm going to graph y less than 1.7. That's going to look like that, but we want the union. So since they don't overlap, let's see, 1.7, 10.4, our union graph, oops, wrong direction there, would look like this, as well as that, and an interval notation, negative infinity to 1.7 in union with 10.4 to infinity. And don't forget to put that symbol between them, implying that it's the union of the two. All right, so for tonight's homework, you've got section 8.4. You're dealing with compound inequalities, double inequalities, unions, intersections. Don't forget, if you multiply or divide both sides of an inequality by a negative number, you change the direction of the sign. If something is included as equal to, it looks like that. If something doesn't include the equal to, it looks like that in terms of graphing. I will be back at 1:15 with an office hour. Should you have any questions? And we'll stop the recording.